Before starting this video, a huge shout out to Code 4. If you're interested in any computer science videos for IGCSE, go and check their channel out. With that being said, let's get on with the video. Welcome guys to this video. In today's video, the topic is stoichiometry. This is basically chapter 4 of the ongoing series for chemistry 0620, and in today's video we will be having a look at stoichiometry. So without further ado, let's just begin and let's first answer ourselves on what is stoichiometry. We're going to start off by answering what is stoichiometry. Now, stoichiometry is just a simple term to show basically measurement. Okay, so when you're doing a reaction, you're supposed to know how much we need to do, how much of the reactants we need, and how much of the products we need, in a chemical reaction. That is basically what stoichiometry is. Okay, and I can show you the definition right here. Let me just quickly show you the definition. This is the definition. I'm going to enlarge it. This is the definition of stoichiometry. It says it deals with the relative quantities of reactants and product in a chemical reaction. So we're going to start off this video by just giving definitions. Now, in this definition, we have two keywords right here. We have something called the reactants and we have something called the product. And we're supposed to know what is the meaning of these reactants and what is the meaning of these products. So I'm going to start off with the reactants. I'm going to quickly show you the definition of a reactant. So here is the definition of reactants. So as you can see here, it's telling us reactants are simply substances or compounds that is added to a system in order to bring about a chemical reaction or added to see if a reaction occurs. So reactants, coming from its name, you can tell these are the ones that react to produce a certain product. Okay, so this is what is called a reactant. Okay, and you need to know reactants, you need to know product in order to understand stoichiometry. This is just a basic of stoichiometry. Okay, the next thing we need to have a look at is products. Okay, so let's get the definition of a product. So here is the definition of a product. Let me just enlarge it so you guys can see. It says here that products formed during chemical reactions as reagents are consumed. So the products are simply because of the reactants. Okay, the reactants will react and will form products in the end of the chemical reaction. Okay, so we'll start off with there. So that's the reactants, that is the products. The next thing you need to understand in stoichiometry is something related to mass, because remember I told you stoichiometry is all about measurement. Okay, and mass is a form of measurement. So the same principle of stoichiometry and mass, we relate these together and we form something called the relative atomic mass and the relative molecular mass. So we have the RAM, which is the relative atomic mass. So we can say right here we have the RAM. Okay, the RAM is simply relative atomic mass. Okay, it is mass. Okay, and we need to know this. So RAM, what is the definition of this relative atomic mass? Let's bring up the definition right here. So relative atomic mass, in simple words, is just simply the mass of an atom of a chemical element exposed in atomic mass units. Here it's written in atomic mass units, which is AR. So the symbol right here is AR, for example 100 AR. Now we'll get into more details in just a minute, but you need to understand what is relative atomic mass first. The next thing you need to know is something called the relative molecular mass. Okay, there's a difference. We have the relative atomic mass and we have the relative molecular mass. The relative molecular mass is basically RMM. So the relative molecular mass you can predict is simply, now we're looking at molecules. Okay, we're looking at molecules. So I'm going to enlarge this so you guys can see. This is the relative molecular mass, and it says that this is the sum of the relative atomic masses of the constituent atoms of a molecule, and this is written in MR. So basically the relative molecular mass is combining all those atoms together that we had in the relative atomic mass to make your molecular mass. So right now, if you don't understand, don't worry, we will be doing examples on how we can calculate the relative molecular mass, how we can calculate the relative atomic mass from given elements and formulas. So that being said, we know the definitions, and the key idea of stoichiometry, first of all, you need to know that reactions can be summarized using chemical symbols. The next thing you need to know that all the reactions has to be balanced, and we have to conserve the law of conservation of mass, because mass is neither created nor destroyed in an ordinary chemical and physical change. So you just need to know the key ideas of how a chemical reaction works. Okay, so those are the definitions. We also have something called the relative formula mass, and the relative formula mass is simply the sum of the relative atomic mass, of an ionic compound in its simplest form. So that's all about the definitions, and that you need to know these definitions by heart. And that's simply what you need to know. Now, of course, we have the calculations, the different types of calculations that you can have in this, and we can do some questions. So let's start off by saying calculating the relative atomic mass and the relative molecular mass. So let's do some examples, and then we will talk about moles, which I will come to that in a bit. So let's start off with calculations. So I'm gonna just quickly write here, let me just enlarge this. Let's start off by calculating the REM and the relative molecular mass. We're going to start off with some calculations right here. So let's start off with the calculations. So we have the relative atomic mass, relative molecular mass. Let's start off, the key ideas is basically the relative atomic mass is simply a number and has no units. It's a number, it's just a number, and for compounds you can use the relative atomic mass to find the relative formula mass. So for compounds, example H2O, right? To find this, we have comprised of hydrogen and we're comprised of oxygen. So you have to simply just add up the relative atomic mass of this. Now, if we get a periodic table, and I will have to find a periodic table to show you this, because in a periodic table you can find the relative atomic mass, and remember, in your exam you will be given your periodic table. So in the periodic table you'll be given you'll be given the relative atomic mass. So I'll just take a picture of the periodic table and I will show you guys right here. So you can take a picture of the periodic table right here. So this is the periodic table, as you guys can see, and this is a similar type of table that you will be given in your exam. Now again, this is just half because I just want to show you the idea. Now, as we have seen this in previous videos, and we know that the larger number is always the mass, and the smaller number is the atomic number. Now there's a difference between atomic number and atomic mass. Now, for example, let's just move into the questions. For example, it's telling us to find the relative formula mass of H2O. It says find the mass of H2O. Give is 1 and oxygen is 16, the mass. Because if we go to the hydrogen, we can see right here the mass is 1. The mass is 1. So you can just write hydrogen is 1, and you can write oxygen is simply it's cut out in this periodic table, but it is 16. Sometimes you're given this in your examination, sometimes you have to go to the periodic table and find the mass. Now in this case, to find the mass, you would simply just see that there are 2 hydrogen molecules, so that means I have to do 1 plus 1, and then there's 1 oxygen, so plus 16. So this will give me 18. So the relative formula mass, or the mass of H2O, is simply 18. So that's basically all about relative atomic mass and relative molecular mass. So to understand this, you just have to go to the periodic table, you have to look at the mass of each, and you have to add them up to find your value. So that's how it is done, as simple as that. Okay, let's move on to the mole concept, and you'll understand more about the molecular formula, moles, and everything related to that. So again, we'll start off with the definitions of all these. So I'm just going to clear the canvas. So now let's talk about moles. Okay, it's a big topic here, and we're going to start off with the definitions. Okay, now moles is simply a quantity or amount of particles. Okay, because remember I told you stoichiometry is all about measurement. Now the type of measurement we use is called moles. Okay, so it is basically, a mole is simply a quantity or amount of particles, okay, which is fixed for any substance, and the unit of course is mole, M-O-L. So let's pull up the definition right here. So this is the definition of a mole. Okay, it's a quantity or amount of particles which is fixed for any substance or unit. The next thing you need to know is something called the molecular formula. The molecular formula is simply the simplest way to represent the actual number of atoms in a molecule. For example, water is H2O. So you also need to know the definition of a molecular formula. So I'm going to show you the definition of a molecular formula. So here is the definition of the molecular formula. The simplest way of representing the actual number of atoms in a molecule, that is called molecular formula. The next thing you need to know is something called the Avogadro's concept, or the Avogadro's constant. Okay, now the Avogadro's constant, in simple words, okay, is simply just the number of particles in 1 mole. Okay, this might be a bit confusing right now, but Avogadro's concept, Avogadro's constant, right? Avogadro's constant is, in simple words, right, a huge number, okay, which is called Avogadro's constant, and it's written as 6.02 times 10 to the power 23, and this basically shows the amount of 1 mole, okay, of any substance. Okay, that is called the Avogadro's constant. So I can also put up the definition of the Avogadro's constant that you also need to know. So right now we're just having a look at the definitions of each and all of them. So you need to know the definitions before understanding the topic. So the Avogadro's constant is the number of particles in 1 mole of a substance. Okay, we now move on. We talk about the molar mass. The molar mass is the mass of 1 mole of any substance. We have the mass number, which we also need to know, and we have talked about the mass number in the previous chapters. Mass number is simply the number of nucleons in an atom of an element. So it's basically the protons plus the neutrons. Now the next 3 that you need to know, okay, we have already talked about it, and this is the relative atomic mass that we just had a look at, the relative molecular mass, and something we call the empirical formula. Okay, the relative atomic mass, which we have already had a look at, is the mass of an atom relative to the mass of a carbon atom, which is sometimes abbreviated to AR. We have the relative molecular mass, which is the mass of a formula, which is calculated by taking the sum of the relative atomic masses, that's the relative molecular mass. And then we have something called the empirical formula. The empirical formula is the simplest ratio of atoms of an element in a chemical formula, which is worked out by the experiment. Now stoichiometry is all about calculations, as I told you, right? Stoichiometry is all about calculations, so you need to know some formulas. So let's start off by writing here calculations, and the first calculation you need to know is, how can I calculate moles? How can I find moles? Now if a mole is in a solid, for example, we have a solid, or we have a powder, or anything that's solid, and we want to calculate the number of moles, we use a simple formula like this. Okay, let me show you the simple formula. This is the simple formula that we use. Mass, okay, we use this, and this can be written, sorry, this is in a bit mixed way, but this is basically a triangle to show the mass and then the number of moles in this. So this can be written as mass equals to the this is the triangle. Okay, so if you want to find the number of moles, you would say the number of moles equals to the mass over the molar mass, or the RAM. Okay, so this can be the RAM. This is how you find the number of moles in a solid. Okay, So let's just quickly go back up, right? So that's the first formula. The first formula says that to find the number of moles, you have to simply do the mass, which is in grams, over the RAM, which is a relative atomic mass, which I told you how to find in the previous topic. The next thing is, what if it is a gas? Okay, because there's another formula for just a gas, and this is the formula for the gas. So if it is a gas, we're saying it is the moles equals to the volume, which will be in dm cubed. It is the value of volume over 24 dm cubed. Okay, this is how you find the number of moles if it is a gas. Okay, if it is a gas, that is how you find the value. And last but not least is you have to have a look at concentration, okay, because sometimes they also ask you to find the concentration too. So to find the concentration, we have another formula. You need to know these three formulas by heart because you will not be given them in the exam. So the last one is concentration of a solution. So we just had a look at three of them. So again, this one can be written in the triangular way, basically moles, concentration. So you can write that concentration moles equals to concentration times the volume. Okay, this is for moles. So let's have a look at the three of the formulas now, all of them together, so that you understand them all together. Now you need to know these formulas by heart. Okay, you need to know these formulas by heart. So let's just copy it right here. These are the three formulas and you need to know all of them. Okay, because you can be asked to find the mole of this solid, find the moles of this particular gas, find the concentration of this solution. Okay, so that is how you sort of get it. Okay, so those are the things that you need to have a look at. Now let's move on to something called the limiting. Okay, let's do an example first of all. Let's do an example first and then we'll move on to limiting reagents. So let's begin. Okay, and let's do a question on maybe let's do a question on just RAM and the basic moles, right? Because you need to understand that first. So we can talk about an example. So it says calculate the mass of 0.5 moles of bromine atoms. Okay, we're supposed to calculate 0.5 moles of bromine atoms. 0.5 moles of bromine atoms. So we're supposed to find the mass in this. So we are supposed to find the mass. How are you supposed to do this? So we use the formula. Bromine is a solid, right? Bromine is a solid. And we use the formula moles equals to the mass over the RAM. Okay, over the RAM. So the moles in this question is 0.5. The mass in this, we have to calculate it, so we'll just write X. And the RAM of bromine, if you go to the periodic table, the RAM of bromine is 80. Okay, the RAM is 80. So you simply just have to do, you cross multiply, so you do 80 times 0.5 to find the mass, and this will give you an answer of 40 grams. Okay, so the mass will be 40 grams. That's how you calculate the moles of, for example, that. Let's do some other questions before moving on, right? It says maybe calculate the mass of 0.5 moles of bromine molecules. Okay, and a bromine molecule contains 2 atoms. Okay, and maybe they give you the MR, and the MR, for example, is 160. So what you simply just do is 0.5 times 160. So 0.5 times 160, and this will give you 80 grams. So that will be the number or the mass. Okay, now let's do another type of question. It tells us how many moles of an oxygen molecule are in 64 grams of oxygen. So we have 64 grams of oxygen, and we are supposed to find how many moles are here. How many moles? Okay, so we have the mass, we have the RAM of oxygen, which we can find from the periodic table. So we know that moles is equals to the mass over the RAM, and I'll keep reminding you. So the mass in here is 64 grams. The RAM of oxygen is 16, and oxygen, hydrogen, carbon is usually always tested. So sometimes you don't even need to go to the periodic table, you will just know the answer. So 64 divided by 16 will give you your answer. Okay, so that is basically the number of moles. Okay, so that's how you can do those types of questions. Okay, so those are basically the calculations of simple molecule moles questions. Okay, so let's move on now and let's talk about something called the limiting reagent. Okay, the limiting reagent, and this is the last topic that you need to know. But before we talk about limiting reagents, let's have a look at how we can calculate empirical formulas, because you need to understand how we can calculate these empirical formulas. So here it says, let's do a question on empirical formulas. Okay, because empirical formulas is of its whole is another big topic, and it tells us 20 grams of hydrogen combines with 80 grams of carbon. Okay, so we have 20 grams we have 20 grams of carbon. Okay, we have 20 grams of carbon, and we have it's 20 grams of hydrogen. Okay, so we have, okay, no problem, we have 20 grams of hydrogen, and we have 80 grams of carbon. Okay, the question is asking us, what is the empirical formula? The formula mass was 30. What is the molecular formula? Okay, so it's basically two questions. Usually these empirical formulas, there are two ways to get this. So the first one is, what is the empirical formula of this? Now there's a simple way to do this. Okay, and you can just first of all write the mass. Okay, so the mass of each, so we have hydrogen here, we have carbon. What is the mass? Here it's 20 grams, here it's 80 grams. Okay, we have done that. Simple. The next thing you're supposed to find is the atomic mass, the AR. So for hydrogen it's 1, for carbon it is, I believe, 12. Okay, so it is 12. After you find the relative atomic mass, you're supposed to find the moles. So you're supposed to find the moles, and we can use the moles to find the, we know moles is equals to the mass over the RAM, right? So the mass of the RAM, so the mass of the RAM, so here will be 20. 80 divided by 12 will be a decimal, which will be 6.67. Okay, and after you find this, you're supposed to find the mole ratio, because empirical formula, it comes from its name, it's a formula. You need to give it in terms of a formula. So what you do to find the mole ratio is you divide with the smallest term, which is 6.67. so I'll divide over 6.67 both sides, and this will give me an answer of 1 and 3. So here it will be 1, here it will be 3. So the final answer will be CH3. That will be the answer of the 1. Okay, that is how we find the empirical formula. Okay, it's as simple as that. Now, given that, for example, the next part of the question will tell you the formula mass was 30. So it tells you the formula mass is 30. Okay, so here it's saying the formula mass, this is usually always part B. So the formula mass is 30. We're supposed to find the molecular formula. So what you do is first you find the RFM, the relative formula mass of CH3, which will simply just be 15, because carbon is 12 and hydrogen is 3. So carbon is 12, hydrogen is 3, so 12 plus 3 is 15, and the formula mass is 30, so 30 over 15. Okay, so this is the mass. Okay, this is the RFM. This will give us 2. So you just multiply everything by 2 to give your answer. So basically it will become C2H6, because before it was CH3. So if now I find times 2, you just do times 2 of everything, and you'll get your answer. It's as simple as that. Okay, so that's how you do it. Quite simple. Let's move on to limiting reagents, or limiting reagent. Okay, so limiting reagents. Reagents is simply you have to find what is in excess. For example, if we use this a certain amount of moles, what is in excess? Okay, so let's give an example for this, and it says 3 grams of magnesium is added to 12 grams of ethanoic acid. It says which is in excess. Okay, so the first thing you would do, maybe sometimes they give you the formula. So it's Mg, which is magnesium, is added to ethanoic acid. Okay, ethanoic acid is simply 2CH3OOH. 2CH3, COOH. So here's C. So here is C. Okay, COOH, and this will give us basically this will give us CH3. You don't need to know this. Usually they give you the formula. So COO, this will be in brackets, it will be 2Mg, and you will get, of course, hydrogen. So this is for the formula, and it's telling us what is in excess. Okay, so the first thing you need to know is you have to find the ratio. So you can see the ratio is 1:2. You have to just look at the front number. Here it's 1, here it's 2, so the ratio is 1:2. Okay, then you have to find the moles of magnesium, find the moles of ethanoic acid. Okay, after you find the moles of both of them, okay, you have to use the formula or the ratio to see which one is in excess. Okay, so it's as simple as that. You don't have to go into so much detail. That's basically how you do it. Okay, so you find the moles, you basically find the moles of magnesium, find the moles of ethanoic acid, and if it agrees in the 1:2, which it'll probably not, because of course it's saying something is in excess, you have to do it. Okay, so find the RAM of magnesium, so find the moles of magnesium, find the moles of this, and then you see which one is in excess. Okay, so that's how you do it. The next thing we need to have a look at is purity yield and purity. Percentage yield is simply the yield, that is the amount of a product obtained, and you can calculate this by yield is equal to the actual mass. So the formula is yield is equal to the actual mass over the calculated mass. So actual mass over the calculated mass, and this is all you need to know about percentage yield. Usually they give you the actual mass, calculated mass, and then you just find this, and then of course do times 100 because you're supposed to find the percentage. Okay, so that's how you do it, and it is as simple as that. That marks the end of stoichiometry. Hopefully you learned stoichiometry in this video, and hopefully you understand this topic, and I'll see you in the next video, which is chapter 5. I'll be uploading more of these videos quite quicker. So thank you for watching this video. I will see you in the next video. Thank you.